everyone. In this video, we're going to look at a practice question related to computer skill related to the learning objective 4. That is calculating the confidence level of mu when sigma is known. Okay, let's look at the question together. A random sample of 100 items is drawn from the population whose standard deviation is known to be sigma equal to 10. And the sample mean is x bar equal to 600. And we want to calculate this interval, the 95% confidence interval for the mu, the population. Okay, so the question number 3 and the 2, go back to the 2, which is the range of the mean. So the mean difference is whether you know the population mean and you try to get the range of the sample mean, or you know the sample mean and you try to get the confidence interval for the population parameter mu. So of course, in question number 3 here, we are given the value of the sample mean x bar. So it's equal to 600. And we want to understand what is the population means confidence interval. Okay, as we understand what this question really asking for, and we just need to open an empty Excel file and just open an Excel file. And so again, I want to re-emphasize for this class, as you work on any statistic question here, you want to make sure as you're reading the question, you write down the value of the parameters so that you're going to use it later on. Okay, so the sample, we know we don't know the mean x mu, we actually know the value for x bar. Okay, so the x bar value equal to 600, right? Let me go back. So x bar value equal to 600. And then my population standard deviation sigma equal to 10. And then my sample size here to get in the 600, the sample size equal to 100. And then the confidence level, as this question talking about, is called 95%, right? So for the 95% confidence, and so we're going to put down, so 95% is 0.95, right? So now, given the lecture, we know the relationship between alpha and the confidence interval is equal to 1 minus the confidence level. That gives me the value for alpha. Okay, now the z. So I don't want you to just z remembering the z. The z statistic is the z statistic we used before to calculate the range of the mean. But here I want to go further to actually teach you how you are able to use Excel to getting that z statistics value. Okay, the z statistics value. So for the z statistic value, the Excel formula we're using is called norm.s.inv. So this is the Excel formula we are using that allow us to figure out that z alpha divided by 2's value. Okay, so now as you type in this formula, they ask you, hey, we only need the one value called probability inside this parentheses. So what is that value we need to use? Okay, let me explain it, what value we're going to use. Let me go back to the normal distribution here. Okay, so let's look at this 95% confidence interval. Okay, this 95% confidence interval. And we want to know what is the z value here. But in order to know the z value here, we need to know at this point what percentage of the area is behind it. Okay, so in order to know the z value here using the Excel formula I just teach you, confidence.s.inv, we need to tell computer what is the percentage of the area by this point. Okay, some students say, hey, Dr. J, I think it's 95.95, 95%, right? 95%. You are not right yet because 95% is the unshaded area, but you still need to include in this one shaded area, right? I was talking about by this point, what percentage of the area are being covered, right? So therefore, you not only just need to include in this 95%, but also you need to include in this area. So as we explained it in the lecture, so this normal distribution is symmetric. So the both shaded area together is 0.5 because both shaded area add together is my alpha's value, right? So therefore, this one tail, this area is symmetric, so it will be the half of my alpha. So therefore, what you need to use inside that norm.s.inv will be your confidence level plus half of your alpha's value. That will give you the value you need to use for the Excel formula. Okay, now let's go back to the Excel to figure out what we're going to put on here. So as I just mentioned, the probability we are using is the confidence level plus half of your alpha. Okay, remember this formula. In order to figure out that z statistic you need to use to calculate your confidence interval, and you need to use the confidence level plus half of your alpha's value. So now you will obtain 1.9569964. So if you only keep 4 decimal places, okay, that's when you also get a 1.9600. So now you know in our lecture, in the previous one, when we are looking at our the range for the sample mean, we just tell, hey, this is 1.96, use it. But now you know how you are actually able to get in the z-score, right? So why this is important? Because now you have the freedom to choose the confidence level, right? Maybe somebody say, I want to know 80% confidence level. So instead of you don't know, now you are able to use the this Excel formula to calculate when it's 95% confidence interval. So I'll give you an example, right? If it's 95%, 80% confidence interval, oops. So here will be 0.8, and then here will be 1 minus, the alpha will become 1 minus your confidence level, become 0.2, right? And then for your z-score for this second case, it will be norm.s.the parentheses, then the probability will be the confidence level plus alpha divided by 2. So if you are looking for the confidence, 80% confidence level, the z statistic value will become 1.28, right, instead of 1.96. Okay, so I'm gonna delete this because we're gonna using the 95% confidence interval. I don't want to confuse you. Okay, now you know all those calculations. Now we're gonna just base on the formula we learned from our PowerPoint, which is this one, right? Let me just copy and paste right next to it. Okay, so now we can base on this formula to calculate the lower bound and the upper bound. Okay, the lower bound and upper bound. So for the lower bound, we're using the minus sign, right? So we pick the x bar minus the z we just calculated times the sigma divided by square root of n. So that will give me my lower bound. So 598.04. Now I'm going to calculate in my upper bound. So that's equal to x bar plus the z statistics times sigma divided by sqrt parentheses and close the parentheses, push enter. So this is my 95% confidence for this example for my for the mu. Okay. So that is the 95% confidence interval from 598 to 601. And so you will have a similar homework questions on Connect. So when we work on the questions, to pay attention on how many decimal places they are looking for. So make sure you're rounding your number properly. Okay, so that's the end of this computer skill lecture, and hopefully help you to learn how to calculate confidence level for the population mean.